Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to see third video of trigonometry. In this video, we will learn about trigonometric functions. So, sign like it is positive or negative in the first quadrant, second quadrant, or third quadrant, and fourth quadrant, right? So we will solve this thing, and apart from that, we will see if the angle is more than 90 degree. Okay, so in that case, value of trigonometric functions, how to find. In that case, we will see how to find value of trigonometric functions, right? So let us see one unit circle here. Okay, so consider this circle. If we can see, this is our first quadrant, this is our second quadrant, this is our third quadrant, this is our fourth quadrant, right? So here all the trigonometric functions are positive. Here sine is positive, here tan is positive, and here cos is positive. So this rule is known as cast rule. So you can just pick the first letter of cos, C A S T. Okay, so we will go in this particular direction. So cast rule is known as C A S T. Start with the fourth quadrant, C A S T. All means all the trigonometric functions will be positive here. Okay, the reciprocal of sine is cosec. The reciprocal of cos will be sec, and the reciprocal of tan will be quarter. So all these functions will be positive in this particular quadrants, right? Okay. Apart from this, if we draw one line over here, so the theta is this one. Okay. So now the components of this particular point will be sine theta and cos theta. Okay. So this is opposite side. So this will be sine theta. So the value of this much will be our sine theta, and this much will be cos theta. So generally, if theta is made with the positive x-axis, so cos component will exist on the x-axis and sine component will exist on the y-axis, right? So from this I can say cos 0. Okay, so this line will be parallel to the x-axis and it will overlap the positive x-axis. So theta is 0. So as we know, this cos component only exists on the x-axis. So if the radius of this circle is plus 1 unit, okay, so the cos 0's value will be plus 1. Okay, cos 90. So now we can rotate this line here. So 90 is here, and we can say that sine component will exist on the y-axis, not the cos component. So cos 90 is taken as 0. Cos 180. Okay, cos 180 is like rotate this line over here. Okay, so this is minus 1, this is plus 1, this is plus 1, this is minus 1, right? So the value of cos 180 will be minus 1. Okay, cos 270's value will be 0, and cos 360's value will be plus 1 again. Okay, after that we can see sine 0 is 0. Okay, now rotate this line here. So sine 90 is plus 1. Okay, rotate this line by 180 degrees. So we will have sine 180 degree, which is 0. Sine 270 is minus 1, and sine 360 is taken as 0. So these are the few values which you can remember using this particular diagram. Okay, so now let us move to the reduction formulas. In the reduction formula, we will learn about how to find the value of trigonometric functions for angles more than 90 degree. Okay, so for the angles more than 90 degree, we can have this kind of angles: 90 plus or minus theta, 270 plus or minus theta, 180 plus or minus theta, or 360 plus or minus theta. 360 plus or minus theta is nearly equal. 360 plus or minus theta is equivalent to 0 degree plus or minus theta. Okay, so whenever we have angles 90 or 270. Okay, so consider we have if sine 90 plus or minus theta or 270 plus or minus theta. In this case, we will change this sine to the cos. Okay, So sine will be converted into its complementary function, which is cos. Cos will be converted into sine. Okay. Tan will be converted into cot. Cosec will be converted into sec. Sec will be converted into cosec. And cot will be converted into tan. If there is 90 or 270. Okay. So this is you have to remember. And the sine of the trigonometric function will be determined by this angle. Okay. So if 90 plus theta hai. Okay. So if we have 90 degree plus theta. Okay. So this angle will be in the second quadrant. And in the second quadrant, sine is positive. So sine 90 plus theta will be converted into just cos theta. Okay. So we will see in detail how to convert these angles. Okay. If the angle is 180 plus or minus theta or 360 plus or minus theta, right? Or it can be 0 plus or minus theta as well. Okay. So in this case, what we will do is, okay, so you will keep sine as sine only, cos will be kept as cos, and tan will be taken as tan. Okay. So there will be no change in the trigonometric functions. Okay. So let us see how to reduce trigonometric functions for angles more than 90 degree. Okay. Our first case is for the 90 angle. Okay. So if we have 90 plus theta. Okay. So for the 90 plus theta, the angle will be in a second quadrant. In this quadrant, sine is taken as positive, as well as cosec is also taken as positive. Okay. So if you are given sine 90 plus theta, okay, and cos 90 plus theta, and third trigonometric function will be tan 90 plus theta. Okay. So okay, so sine 90 plus theta. Okay. So sine 90 plus theta, 90 plus theta lies in the second quadrant. Okay. And sine is positive in this particular quadrant. So the value of sine 90 plus theta will be cos theta. We change sine to the cos. The reason being here is 90. Okay. Now cos will be converted into sine, and you can just put theta. But cos is negative in the second quadrant. So there will be a sign of negative. Okay. Tan will be converted into cot theta, but the sign will be negative. Okay. Now let us move to the second uh, kind of angle, which is 90 minus theta. Now 90 minus theta is in the first quadrant, and all the functions are positive. Okay. So sine 90 minus theta, cos 90 minus theta, and tan 90 minus theta. Okay. So sine will be converted into cos theta. Okay. And all the functions are positive. So here sine will be positive. Cos 90 minus theta will be converted into sine theta. And tan 90 minus theta will be converted into cot theta. So these are the values for 90 minus theta. Okay. So you can just directly remember, if sine is there, then you will directly convert it into cos. If cos is there, you will convert it into sine, and tan is there, then you will convert it into cot only. Okay. Our third angle is 270 minus theta. Okay. The 270 minus theta, here theta will be taken between 0 to 90 degrees. So 270 minus theta will be in the third quadrant. In the third quadrant, our cos is so in third quadrant, only tan is positive. Apart from tan, cot is also positive, right? So now let us put sine 270 minus theta, cos 270 minus theta, and tan 270 minus theta. Okay. So here there is a 270. Okay. So for the 270, we will change trigonometric functions into their complementary functions. Okay. So sine will be converted into cos theta. It will be negative. The reason being here only tan and cot are positive. Okay. Cos will be converted into minus sine theta, and tan will be converted into cot theta. Okay. Our fourth type of angle is 270 plus theta. Okay. So in this case, what we will do is, okay, so sine 270 plus theta, cos 270 plus theta, and last is tan 270 plus theta. Okay, so 270 plus theta is in the fourth quadrant. In the fourth quadrant, cos is positive and sec is also positive. Okay, so sine 270 plus theta, sine will be converted into cos theta and it will be negative. Cos 270 plus theta will be converted into sine theta and it will be positive. And 2 tan 270 plus theta will be converted into cot theta and it will be negative. Okay, so this is the main fundamental which you need to remember is if 90 and 270 is there, then you will convert it into their complementary functions, and this positive and negative sign will be determined by this function only. Okay, not this function. Okay, if you are finding sine 270 minus theta, then you will see the sign of the that function in the particular quadrant, not the like converted trigonometric function. Okay, so you have to remember this thing. Okay, for next type of angle is fifth, which is 180 minus theta. So 180 minus theta is the second quadrant. In the second quadrant, sine is taken as positive, and apart from sine, cosec is also positive. Okay, so sine 180 minus theta, cos 180 minus theta, and last is tan 180 minus theta. Okay, so sine 180 minus theta. Okay, now here we have 180. So for the 180, 360 and 0 degree angle, we will just keep our function as it is. So it will be sine theta. But the sign of the positive and negative sign of this, but the sine 180 minus theta, here it is in a second quadrant and sine is taken as positive. So it will be positive. Cos 180 minus theta will be cos theta. And in the second quadrant, cos is negative. Tan 180 minus theta will be converted into tan theta, but it is negative. Okay. Sixth is 180 plus theta. Okay, so this is third quadrant. In the third quadrant, our tan is positive. Also, cot is positive. Okay, so now we have sine 180 plus theta, cos 180 plus theta, and last we have tan 180 plus theta. Okay, so sine will be converted into sine theta, but it will be negative. Cos 180 plus theta will be converted to minus cos theta, and tan 180 plus theta will be converted into plus tan theta. Okay, so this is third quadrant, that's why tan and cot will be taken as positive. Our seventh type of angle is 360 minus theta. Okay, so 360 minus theta is just equal to 0 minus theta, which is just our minus theta. Okay, so if we have like 4 axis like this, our angle will be here, so this is just minus theta. Okay, so we will just find sine minus theta, cos minus theta, tan minus theta. Okay, so this is our fourth quadrant. Yes, in the fourth quadrant, our just cos is positive. Okay, so sine minus theta is minus sine theta because here being 0 or 360. In this case, we just keep our function as it is. Cos minus theta will be cos theta and tan minus theta will be minus tan theta. So this is how we can just find the angles. So this is how we can just reduce. This is how we can just reduce our trigonometric functions into their final trigonometric functions. Okay, so here you can remember sine minus theta will be minus sine theta, cos minus theta will be cos theta, and tan minus theta will be minus tan theta. Okay, apart from this, the eighth our angle is 360 plus theta or 0 plus theta. Okay, so this is just nearly equal to your sine theta, cos theta, tan theta. Okay, so this is all about how to reduce your trigonometric functions if angle is more than 90 degree. Okay, now let us look into some examples so you just can apply this method to any kind of problem. Okay, so examples, consider first is sine 120. So for the examples I have just simple method. Okay, you can just put it sine 180 minus 60. Okay, so 120 is in the second quadrant. Okay, and in the second quadrant sine is positive. Okay, so sine 120 will be positive as well. Okay, so as we remember, if angle is 180, so our function will be as it is. So it will be sine 60, which will be equal to root 3 by 2. So in case of 180, we just don't change our trigonometric functions. So this is quite easy to convert our so this is quite easy in case of 180 or 360 degree angle to just keep it. So it is so it is too easy when the angle here is 180 or 360. We can just keep our trigonometric function as it is, right? Our second type of example is cos 120 degree. So you can just write it cos 180 minus 60. Okay, so this is also our second quadrant. So cos is negative in the second quadrant. So you can just put minus sign here, and this will be cos 60. It will be minus half. Okay. For third type of example is okay. So now let us have one tan value here. So consider tan 150. Okay, so you can write it tan 180 minus 30. This is also in this this is also in the second quadrant. It is negative, so it will be minus tan 30. The value of this function will be minus 1 by root 3. Okay. Our fourth kind of example is consider if the angle is in the third quadrant. So we can have one angle which is sine 215 or maybe 225. Okay, so you can write it sine 180 plus 45. Okay, so as we know, if angle is 180 plus theta, so we will keep our trigonometric function as it is. So this will be sine 45. But in this case 225 is in the third quadrant and sine is negative in the third quadrant as from the cast rule. So this will be minus sine 45. So the angle will be minus 1 by root 2. Okay, our fifth kind of example is cos 240 degree. It will be cos 180 plus 60. So in the third quadrant cos is negative, so you just put minus cos 60. Okay, so this will be minus 1 by 2. A sixth kind of example is tan 233. This is tan 180 plus 53. Okay, so here we can see the angle is 180, so we will keep our trigonometric function tan as it is, and also in the third quadrant tan is positive, so this will be tan 53, and tan 53's value is 4 by 5. Okay, so from the trigonometric table you can just check this out. Okay, now let us have one angle which is more than 270 degree and between 360 degrees. So that will be our fourth quadrant, right? So our seventh example is sine 315 degree. Okay, so I can take it as sine 360 minus 45. So here you can see in each of the reduction formulas, I have just used 0 and 180 degree because it is much easier when you have to deal with the 360 and 180 or 0 degree. The reason being you have to just keep your trigonometric function as it is. Okay, so sine 360 minus 45 will be our minus sine 45. The reason being sine is negative in the fourth quadrant, so the value of this function will be minus 1 by root 2. Okay, eighth is cos 300. So this will be cos 360 minus 60. Okay, so this will be plus cos 60. The reason being the cos in the fourth quadrant is taken as positive. So this is 1 by 2. Ninth is tan is 30 degree. So this is tan is 60 minus 30. Okay, 360 minus 30 is okay. So tan is negative in the fourth quadrant. So you just put minus tan 30. This will be minus 1 by root 3. Okay. So this is how you can just reduce the formulas whenever you are given. Okay, our 10th example is for the minus theta angles. Okay, so sine minus 30 is just minus sine 30. The reasoning, this will be in the fourth quadrant. Minus sine 30 is minus 1 by 2. 11th example can be taken as cos minus 45. So cos minus 45 will be plus cos 45. This will be 1 by root 2. And our 12th example is tan minus 30 degree. So this is minus tan 30 degree. This is minus 1 by root 3. Okay, so this is how you can just solve each kind of trigonometric functions by reducing their so using this method you can reduce any kind of trigonometric function and you can find the value of that particular trigonometric function. Okay, so that's all for the trigonometric series. This is all about required trigonometry which you need to solve physics problems, right? So if you have any kind of doubt, just you can comment or you can mail your doubt at physics@gmail.com. Okay, so I will try my best to reply your queries. Thank you so much.